In this video, we're talking about polynomial multiplication. We'll talk about how to multiply polynomials using an area model and also using the distributive property. Before we get started with polynomial multiplication, one vocabulary word you need to be familiar with is that of polynomial identity. Okay, a polynomial identity is a statement that two polynomials expressions are equivalent, meaning they're always true. So here's an example. X plus 3 squared is equal to x squared plus 6x plus 9. Okay, that is true for any number, real number x, and we can show that using an area model or distributive property. Okay, another example would be, let's just say like x plus 2 is equal to 2x plus 2. Okay, that's also true for any real number x. Okay, some non-examples of a polynomial identity would be that 2x equals 8. Okay, that's not true for all real numbers all real numbers. It's only true for some of them, in this case, the number 4. Okay, or if I change this to be x minus 3 squared is equal to x squared plus 6x plus 9, that this one is also not always true. So we then need to be able to figure out mathematically when is it true, and so it's not a polynomial identity. Okay, so after that discussion, let's jump into how you do polynomial multiplication. Okay, we'll do this one with both called the tabular method, meaning an area model to multiply these, and also the distributive property. Now, before I actually do this one, I actually want to go up here and look at this area model with numbers. Okay, you may have seen this in previous classes. You probably have. So this, if I want to show that 28 times 27, one way to do this is to think of 28 as 20 plus 8. Okay, and I'll put that here, 20 plus 8. The length of this side right here is 28, which I'm expressing as 20 plus 8. Okay, and then this length right here will be 27, which I'll express as 20 plus 7. Okay, and now I can find, now I have 4 spaces in here that I can find the area of each one. Okay, the square right here is 20 times 20, which is 400. And this rectangle right here is 20 times 8, or 160. The rectangle down here in the bottom left is 20 times 7, or 140. And then the rectangle in the bottom right is 8 times 7, which is 56. Now, the way I figure out what 28 times 27 is I add up all of the squares and rectangles in here. So I add 400, 160, 140, and 56, and I get 756 units squared. Okay, so that's an area model that you've seen before. Okay, we can do a very, very similar thing with polynomials. Okay, so here we have, we're multiplying x plus 8 and x plus 7. Okay, notice up here we have x plus 8 as this length right here, and we have x plus 7 as this length right here. Okay, and we'll do the exact same thing. This upper left corner is x times x, which is x squared. Okay, this upper right corner is x times 8, or 8x. And we have this bottom left corner as x times 7. I'm getting that from the numbers on the sides. And I get 7x. And then in the bottom right, I have 8 times 7, or 56. Okay, it's the same process as before, just with some variables like x in there. Okay, the fun thing about the area model is that when we combine like terms, diagonally, as long as we do it correctly and line things up correctly, things line up diagonally very nicely. Okay, so this diagonal adds to be x squared. Okay, this diagonal, 8x plus 7x, adds to be, because those are like terms, adds to be 15x. Okay, and then the other 56 is, the constant terms. There's no variables there. And that's it. Okay, now we can do the exact same problem using the distributive method. And now we're looking at, I'll just do it right here, x plus 8 times x plus 7. I'm going to distribute the x into both this x and the 7. So x times x is x squared. X times 7 is 7x. Okay, I will also distribute this 8 into both of these terms. X times 8 times x is 8x, and 8 times 7 is 56. Okay, notice I get the same numbers, they're just not organized into a table or as an area. I now combine like terms, which again, these are like terms. It's not as organized as nicely, but I can still do it here. And I have x squared plus 7x plus 8x is again 15x plus 56. Okay? In truth, if I ask you to do it using a certain method, you should use that method. Okay, but most of the time, really you're on your own to pick which method. So whichever one you feel more comfortable with, I will be totally honest and upfront that I tend to use the distributive method, and many students choose to use this bottom method because it's faster and it takes less space on your page. But you're always welcome to use the tabular method to multiply polynomials. Okay, this next page has a lot of identities and discovering patterns that I think are really interesting, but not necessarily essential. So for this one, for example, notice that we have some different signs. So this right here is negative, and these all are positive. So, and they've done a tabular method, an area model for us, and notice all of these diagonals just cancel out. They cancel, 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 cancel. And so what you're left with is x to the 5th minus 1 is what those multiply together to be. Okay, so interesting patterns happen with different signs. Okay, I'm not going to do all of these for the sake of time in this video. You can go ahead and look at them. They're very interesting. But the opposite signs that are here do create some interesting patterns and some identities that we can look at. Okay, I'm going to keep going and looking at the ones down here. Now, I'm not going to do all of these, but I'll do some of the more complicated ones. So I want to try this one, and this says use the tabular method to multiply and combine like terms in standard form. Okay, and watch your like terms. I'm going to do letter B. Okay, that one looks kind of scary and one that's bigger than I've seen in this video so far. Okay, I'm doing this one. Now, I'm going to put the 3. Now, first of all, are they in descending order? They're in standard form, both of them, okay? And there's no missing term. That's an important piece to point out. There's no like missing m squared term or m term or any missing terms. Like, anyway, that's being skipped. So I have 3m cubed, excuse me, okay, plus m squared minus 2m minus 5. Okay, that's kind of my top. Okay, my side is going to be m squared and minus 5m. You may make sure you keep those signs, the negative signs, and minus 6. Okay, now I know it's an area model. I'm not trying to duplicate exactly, the right dimensions. Like m cubed obviously is bigger than m squared as long as m is bigger than 1. But I'm not trying to duplicate that. I just want to find regions that I can think through this problem. Okay, so now I'm multiplying the top number by the left number, okay? And here's where your exponent rules become very, very important, okay? So 3m cubed times m squared is 3m, and then I will keep the common base, and I will add the exponent. So 3 plus 2 is 5, because I have 3m's times 2 more m's, I have a total of 5 m's. That's 3m to the 5th. Okay, here I have in this region right here, m squared times m squared. I have, keep the common base, you add the exponents. Please pause the video and try the rest of these, and then push play, and I will do the rest to make sure that our answers match. So go ahead and pause the video. Okay, how'd you do? So this is what I got when I filled out by multiplying the top and the top and the right sides. And again, as long as everything lines up, now this is a good check for you to make sure that everything is correct, but I should have these should be all like terms. And if you don't have them as like terms, that's one way to check yourself that you're doing it correctly. Okay, for me, it looks like they all are like terms, and so, you know, I'm on the right track. Okay, I'm now going to combine like terms, so this is just 3m to the 5th. Okay, this second diagonal, I have negative 15m to the 4th plus 1m to the 4th, so I have negative 14m to the 4th. Okay, next in this third diagonal, the m cubed diagonal, I have negative 18m cubed minus 5m cubed minus 2m cubed. So let's see here, that's going to be negative 25m cubed. In the m squared diagonal, I have negative 6m squared plus 10m squared minus 5m squared, and that's negative m squared. Okay, and then 12m plus 25m, how many m's do I have? Well, I have 37 m's, and then plus 30. Okay, so this becomes what I get after multiplying those using the tabular method, or using an area model to multiply these polynomials. Okay, on the next page, we have using the distributive method to multiply these. I'm going to do only 2 of these. To show you how to do it, I'm going to do this one, okay? And in this distributive method, you're just multiplying each term on the left with each term on the right, okay? So I have x squared times x squared. Again, these are where our exponent rules come into play. I will keep the common base, and I will add the exponents. 2 plus 2 is 4. X squared minus 2 is negative 2x squared. Okay, so go ahead and pause the video and try the rest of these, and then push play, make sure that our answers agree. Okay, that's what I got after distributing. I will now combine like terms. Okay, now notice things are not necessarily in a nice order for me, so I have to be careful about how I combine like terms. It looks like I only have one x to the 4th term and only one x to the 3rd term. It looks like I have 2 x squared terms, so combining like terms, negative 2x squared, don't forget that negative, plus x squared is I have negative x squared, and negative 1x squared. Okay, looks like I only have one x term, and then minus 2. Okay, so these is, a little trickier than maybe the area model might have been. But it is more concise. It does take less time once you get good at it. Okay, the next one I want to do is letter C, because that one is just a little bit different. So I'm going to distribute, again, everything on the left with everything on the right. And there's only one thing on the right. So negative 5w times w squared is negative 5. Now w times w squared, I have one w, 2 more w's. I have a total of 3 w's. And then negative 3 times w squared is negative 3w squared, and that's really all there is to it. Okay, that's the distributive method. It is one that I tend to use more often because it's more concise and it's faster once you get really good at it. In number 3, we'll multiply and combine like terms to write the sum or difference of monomials. Look for patterns or identities to make it easier or faster for you. Okay, now this is alluding to the patterns that we kind of skipped over a little bit on pages 4 and the top of 5 in this packet. Anyway, so we've not gone over those, and so we won't see those patterns, but we'll do these using polynomial multiplication. Okay, number 3a I will do, and that one looks a lot like the distributive property. I think it makes more sense to use the distributive property here. So I'm going to distribute 1/8 times 96z and 1/8 times 24z squared. Okay, now in case you've forgotten how to multiply fractions, 1/8 times 96. Now the way you multiply fractions is you don't need a common denominator, it's only adding and subtracting. Okay, I'll make this over 1, and I can multiply the tops and the bottoms together. Or what I end up getting, well, let's just do that, yeah. The tops together is 96, the bottoms together is 8 times 1 are 8, and 96 divided by 8 is 12. Okay, now another shortcut, just to remind you of this fact, is that you can cross-cancel in multiplication. And so you could have canceled here, and it would have been just one fewer step, just to give you a heads up about that. But the point is 1/8 times 96z will be 12z. Okay, and then 1/8 times 24 is you get 24 over 8, which divides to be 3. Okay, and so we get plus 3z squared. Okay, now this is not in standard form because I have the z squared after the z, and so I'll rearrange these just to put it in standard form for my answer to get in the habit of doing that. And that is my answer for this one. Okay, so that's the distributive property. I'm going to go ahead and do letter C. Now this one I could do using either method, and so I'm going to use the area model to show you that you can use either one. Okay, so go ahead and pause the video and try this one using the area model and see what you get. Okay, so notice that the 10w and the negative 10w, that this diagonal right here cancels out to be 0w. Okay, again, I mentioned that those alternating signs do create some interesting patterns that if we would have gone through the previous page, we would have noticed, oh yeah, that's, different signs, and so we get the first thing squared and then minus the second thing squared. Okay, it's a pattern we can notice, but you can do this using either the area model or the distributive property. Okay, the last one I'll do in this video is letter E. Okay, again, this is another pattern that we kind of skipped over, but we can do this using either model. I am actually going to use the, I'll just use the distributive property, so it's different than letter C. But this one, also has some things canceling out, just like we saw in C. But I'll use the distributive property. Go ahead and pause the video and try this one. And when you finish, then go ahead and hit play. Now for this one, I'm actually going to line these up. You can do this to line them up in columns so it's a lot easier to see. I'm going to put my minus w to the 5th right here under the other w to the 5th, just so I can see how it'll cancel out later. Now to combine like terms, I get w to the 6th. Notice this cancels, and this cancels, and this cancels, and this cancels, and this cancels, minus 1. This video is about polynomial multiplication, both using an area model and the distributive property. Thank you for watching.